We're going to be looking at the introduction to probability. This is going to be probability events. So when we're talking about a probability, we're thinking what is the chance or likelihood something will actually occur. Most of the time we're thinking about a spinner, a dice, drawing something from a deck of cards, drawing something from a bag or a hat, any types of situations like that. Specifically, in this first part, we need to talk about what mutually exclusive events are. Mutually exclusive events are two or more events in which there is no overlap. So for instance, if I had a dice, there are six numbers on a dice, the odds of me, or the probability of me rolling a 1 and the probability of me rolling a 2, those are two separate events. They do not overlap. Now, if I were to say, if I had that same dice and I wanted an even number or a 2, well, a 2 and an even number have an overlap. So therefore, that would not be a situation that's mutually exclusive. If you have a mutually exclusive event, we have a certain type of probability. So the probability of event A or event B equals the probability of A plus the probability of B. Okay, so that's if they are mutually exclusive, we have no overlap. If there is overlap, then our probability is going to be 0 because we have that situation in which there's an overlap occurring. So let's look at an example. A spinner is split into 8 equal sections. What is the probability of spinning a 2 or an odd number? So the first thing you want to ask yourself is, do you have a mutually exclusive event? If so, then you can continue. If not, then you just say it's null or 0. So in this situation, if I'm spinning a 2, the probability of that occurring is going to be 1 out of 8. The probability of spinning an odd number, so sometimes I like to list out my actual scenarios so then I can see what my probability is. I'd have a 1, 3, 5, or 7. So that is going to give me a probability then of 4 out of 8. So setting up my mutually exclusive probability situation, I have P of A plus P of B. So in my situation, I have 1/8 plus 4/8 to give me 5/8. And there's a simple probability situation. Now, we also have what is called a complement. Now, a complement, it's not like where I say, oh, that's a nice shirt. This situation is going to be that an event that is not occurring. And this probability is 1 minus P of A. Now it's always 1 because our probability is 100%, which would give us that 1. And then you're subtracting off whatever the probability of the event is actually going to occur. So, what is the probability that you do not roll a 6 on a die. So I look at it, okay, what is the probability of actually rolling a 6? Probability of rolling a 6 is 1/6. So the probability of not, I shouldn't leave it as P of C, is going to be 1 minus 1/6, which gives us 5/6. So pretty self-explanatory on that situation. So we've talked about mutually exclusive, complements. Now we've got mutually inclusive. So we have some type of overlap occurring in the events. Ooh, sorry, getting a little tight there on my cursive. Not really cursive, but you guys get my point. So the probability of A or B, this is going to be represented of P of A plus P of B, but we have to subtract off the events that are overlapping. I shouldn't do it as a plus. It's okay. So, what is the probability of rolling a number greater than 3 or an even number? Sorry, computer froze there on me, and of course it recorded blank error. Sorry about that. So let's look at those different situations. So if we have greater than 3, I'm just listing out my options. This could be a 4, 5, or 6. So my probability is 3 out of 6. And then if I have a probability of even, my numbers are 2, 4, 6. And then my overlap is the 4 and 6. So that's going to be 2 out of 6. So what I'm going to do here is I have 3 over 6 plus 3 over 6 minus that overlap. So when I do that, I end up getting 4 out of 6 equals 2/3. And that makes sense. Some people will just look at this and say, okay, I know the 4 and 6 overlap, so I'm going to take those off regardless. The last thing that we need to talk about is independent events. I know, kind of a lot of vocab. With independent events, you are having 2 events in which the first one does not affect the probability of the second one. And this situation is going to be represented as multiplication. We'll talk about dependent events in the next video, but just so you guys are aware, independent events, you're going to have generally the other thing you want to look for in these different situations is replacement occurs. So for instance, when you're talking about rolling a dice, how I roll that first option is not going to affect how I roll the second option. They aren't, that first roll and second roll aren't dependent upon each other. If I'm talking about, starburst, for instance. If I select a red, I'm probably going to eat that one, and then a pink. Well, then that affects it because that red option is gone. I ate it. But so we're just looking at independent events where we're going to have that multiplication. So let's say that a drawer contains 6 white socks and 4 black socks. What is the probability of selecting a white sock, replacing or changing my mind, and then selecting a black sock? Because I gotta wear black dress pants, so I can't wear those white socks. I had to, put those black socks on so I look fashionable. So probability of selecting a white sock first is going to be 6 out of 10. I'm multiplying, I put that sock back in the drawer, and I then select a black sock, which is now going to be 4 out of 10. So I just multiply these straight across, and then I reduce. And my probability is 6 over 25. So kind of a lot of information. We talked about independent events, mutually inclusive and exclusive, as well as complements.